Assalamualaikum warahmatullahi wabarakatuh. Hello guys, my name is Alvin Irwanto from Natural Language Processing class. In this video, I will try to answer and explain about the question that already given as a major assignment 1 in Natural Language Processing class. So without any further ado, let's get started. Okay, let's start with the first question, that is, what is the definition of NLP? So, natural language processing, or we can say NLP for short, is a part of artificial intelligence that makes computers or machines understand what we are saying and can respond like humans do by using text or even speech by their sound. In short, it is a machine that processing the text to get the meaning inside of it and turn it into something useful. Okay, let's move to the next question. Apart from the text segmentation, what are the challenges of data processing or research in the field of NLP? So, I think there are several challenges that we might face in the field of NLP research. First is slang and idioms. Slang or idioms are quite difficult to process in NLP because the writing is very different from the real meaning. Therefore, the machine will misinterpret the sentence that it should be. Furthermore, cultural slang is constantly morphing and expanding, so new words pop up every day. The second challenge is the ambiguity. Ambiguity means a word or sentence that has the potential to have more than one meaning. An example is a word that could be used as a verb, noun, or adjective. Even for humans, this sentence alone is difficult to interpret within the context of surrounding text. The third is the sarcasm. So sarcasm can cause a problem in NLP because machines can misinterpret the meaning it contains, because sarcasm itself has a different connotation from what is actually written. Many sarcasm have positive words when they actually have the negative meanings. And the last is homonyms. The homonyms themselves have the meaning of two or more words that are pronounced the same but have different definitions. For example, the sentence "you are running out of time" and "you are running to the school" have a different meaning even they are using the same word, that is running. Okay, let's move to the third question. What is an example of implementing NLP in software? So the first is Google Translate. There are actually so many implementations, but in this video I will only explain two of them. First is Google Translate. So we can easily capture our speech and the machine can understand, and it can transform our speech into text that we want to search. And another example is the personal assistants. For example, is OK Google, Cortana from Microsoft, Siri from Apple, also Alexa from Amazon. So using these personal assistants, we can say a command and it will do what we command if we already integrate it with another device that also support, of course. And the fourth question is, what is the use of NLTK in Sastrawi libraries? So NLTK, or Natural Language Toolkit Library, is a platform that used for language data or natural language processing based on Python programming language. So it contains libraries and program for NLP, also contains package to make machines understand human language and reply to it with an appropriate response. And for Sastrawi, it almost same like NLTK, but it used for stemming the text that based on Indonesian language or Bahasa Indonesia. There's also a Python library, but it is a development from the library before that used the PHP as a base of programming language. The fifth question is, what is the purpose of case folding? So the first is change all the letters in the document into lowercase. The second is removing number. The third is removing punctuation mark. And the last is removing white space. So in this purpose, we only accept letters from A to Z, and the rest of them will be delimiters. Okay, the sixth question is, what is the definition of tokenizing? Tokenizing is a process of separating the phrases into pieces of words called tokens that we will use for analysis later in the next process. So these tokens help in understanding the context or developing the model for the natural language processing project. The seventh question is, tell me about stop words and give examples. So stop words is a commonly used word that usually appears in large numbers, and it's considered meaningless because if we remove it, it is not lost the intended context. So if we remove these words, because it will take more space in our database if we keep it, also take more time when we process it. The example of stop words are the, and, in, can, I, etc. So the eighth question is, what algorithms can be used for stemming in Indonesian text? And explain it. Okay, one of the best algorithms that can be used for Indonesian stemming process is the Nazif and Adriani algorithm. So this algorithm is a stemming algorithm for Indonesian text, of course, which has the ability to have a percentage of accuracy precision better than other algorithms. It is very rare that the algorithm used for stemming Indonesian because the stemming process in Indonesian text is more complicated or complex, because there are variation of prefix that must be removed to get the root word in the word. So for its own use, there is already a library in the Python programming language that can be used for stemming, namely the Sastrawi library. So Sastrawi library itself is the best of Sastrawi library itself is use the Nazif and Adriani algorithm. So the ninth question is, what is the purpose of word embedding? So the purpose of word embeddings is, if you want to do the machine learning, so you have to put the data that can be easily understood by the machine. So more simple the data, the machine will be easier to process it and get a better performance also. One of the purpose of word embeddings is a numeric vector input that represent a word in a lower dimensional space. It allows words with similar meanings to have a similar representation. Another purpose of word embeddings are to reduce dimensionality and to use a word to predict the words around it. The 10th question is, state and describe the architectural model of word-to-vec. So the architecture of word-to-vec itself is divided into 3 layers that are input, projection, and output. The architectural model of word-to-vec divided into 2 that are skipgram and continuous bag of words, or we call it SIBO. So the skipgram, it will take the central word closer to the neighboring words. So it is showing that this method produces more meaningful embeddings. The purpose of skipgram architecture is to predict the context output around the current word or input. And for the continuous back-and-forth or SIBO, it is the complete opposite of skipgram model. So in this model, it will try to fit the neighboring words in the window to the central word. Its purpose is to predict the word or output when given the context around the word input. The 11th question: what is the definition of back-and-forth? So back-and-forth is a method to get the features or words from the text document. So it creates a vocabulary of all the words that appear in the text. For example, I have this sentence. The first is I have a pen. Second is I have an apple, and the third is I have a pineapple. So after applying the bag of words, we will get the I have a pen and apple, pineapple. So the same word like I have and a will not be entered into the vocabulary again because it already used before. So it like use a set in math, if you know, also the programming language. The 12th is telling me about the fast text algorithm. So the fast text is a library that contains method that can be used in a word embedding. Fast text itself is upgrading from the word to fact, which is already known for a long time. The advantage of fast text itself compared to word to fact is the fast text has the ability to handle words that have not been encountered before, while in the word to fact library or the traditional one-hot encoding technique described earlier will generate an error when it receives a word that is never in the dictionary. The 13th question: what is the meaning of n-gram? So n-gram is a process that is widely used in the text mining and language processing. An n-gram means a sequence of n words. So for example, my name is for example, the word Alvin Irwanto is a 2-gram, or we call it bgram. The sentence a good reason for is a 4-gram, and the sentence like you are is a 3-gram. The n-gram is used in various language processing process. An n-gram is used not only using unigram but bigram and 3-gram models are also used. So Microsoft and Google use this model for their web development, some of which are used for several tasks such as spelling correction, word breaking, and text summarization on their web. But not only in that case, n-gram is used also in the supervised machine learning process such as max-ent and knife-based and etc. So the 14th question: describe an example of applying n-gram. So n-gram are used for a variety of things. Some examples include auto-completion of sentence such as the one we see in the Gmails these days, auto spell check, or to a certain extent. We can check also for grammar in the given sentence using the Grammarly plugin in a Google Chrome. This is the example of applying n-gram. So you is a unigram, I love is a bigram, I did not is a 3-gram, better than your thing is a 4-gram, and etc. For example, we have a sentence, I go to school this morning. So in the unigram it will look like I go to school this morning. It's just breaking into one word, and in the bigram it will look like the sentence below, I go to school this, this morning, so divide it into big gram and etc. It's just an example. The 15th question is what is the definition of smoothing? So smoothing techniques have been used in NLP to resolve situations such as evaluating the probability or likelihood estimate of a set of words, say a sentence, appearing together. So when one or more words individually or unigram or n-gram such as bigram or trigram in the given set have never happened previously. So when doing the NLP, this is a basic technique that can be applied to most machine learning algorithms. 16th question is tell me about Laplace smoothing. So Laplace smoothing, or also known as advanced smoothing, is a smoothing technique that solves the issue of zero probability. The likelihood is determined after 1 is applied to all the counts in the Laplace smoothing. Out of all smoothing techniques, this is one of the most basic. The 17th question, what is the definition of backoff and interpolation? So backoff mean when you come across a term with probability equals 0, you go back to the n-1 gram stage to measure the probability. So we turn to a lower language model when we don't have enough data to trust our key model. If you have trigram, it will use it. If you don't, it will use bigram, and if you don't, it will use the unigram. And for the interpolation means to find the term that you want to look up, it will use the combination of the unigram, bigram, and trigram. 18th question, explain why the Nizar-Ney smoothing method performs so well. So it is generally recognized as the most effective method of smoothing because the use of absolute discounting to omit n-grams with lower frequencies by subtracting a fixed value from the probability's lower order terms. So for both higher and lower order n-grams, this method has been found to be equally accurate. It operates in almost similar way to good Turing smoothing in that absolute discounting is applied to the count of n-grams and the product of interpolation weight and likelihood of words appearing as a novel continuation is added. The 19th question, what is the background for the development of the stupid backoff method? So the stupid backoff method is created by Thorsten Brands, Ashok C. Popat, Peng Shu, Franz J. Orr, and Jeffrey Ding from Google. They introduced it as a new smoothing method that is inexpensive to train on large data sets and approach the quality of Nizar-Ney smoothing as the amount of training data increases. So the stupid backoff doesn't generate normalized probabilities. The key difference between stupid backoff and other smoothing methods like Nizar smoothing, cuts backoff, and linear interpolation is that stupid backoff doesn't use discounting and instead use relative frequencies directly. In the distributed environment, stupid backoff is inexpensive to measure while approaching the quality of Nizar smoothing for large quantities of data. The language model's performance in the environment is unaffected by the lack of normalization since it's based on the relative rather than absolute feature function values. And we go to the last question, it's the 20th question, what is the rationale for the good Turing smoothing method? So the basic idea behind the good Turing smoothing approach is to determine how much mass to pass to unseen events by using the cumulative frequency of events that occurs only once. All events that occur k times in the training data have their probability mass reassigned to all events that occur k minus 1 time. When this diagram has never been seen before in the corpus, like likelihood without smoothing will be 0. Okay guys, thank you for watching my video. Hope you like it and learn something new from that. And don't forget to like, comment and subscribe in the section below. And see you on the next video. Thank you.